Okay, we're going to start lesson 16, laws of logarithms. So let's run through those real quick. So you have a logarithm with the same base being added to another logarithm with the same base. That can be changed to multiplication. If the logarithms have the same base and you're subtracting, that gets changed to division. And if you have a number times a logarithm, that number becomes the exponent. And those are your three laws of logarithms. Let's apply those. Okay, so we want to simplify the left-hand side, changing that addition to multiplication. 5 times x plus 2. And then we'll change that to exponential form. So we get 4 to the second is equal to 5 times x plus 2. So 16 equals 5x plus 10. Subtract and divide. Always check your answer. So when I plug 6/5 back in, it's going to come out to a positive. And as long as our argument's positive, then we're good. All right, let's look at one that may not work. This time we're subtracting. And what does subtraction change to? Okay, it's going to change to division. And this time we have the same logarithm on both sides, so we can cancel it. So I have x minus 1 over x plus 2 is equal to 14. We can cross multiply that. Subtract the x, then subtract the 28, and divide. Now that when I plug that back in, it's going to give me a negative answer. So this one has no solution. We didn't mess up. There's just no solution for that one. Okay, let's look at a number times a logarithm. Okay, the number becomes the exponent, so it's going to change to an x squared. And then addition is going to change to multiplication. Can't cancel the logs because they're not on both sides, so we have to change to exponential. So 8 to the first is equal to 4x squared. Divide by 4, square root. Okay, square root of 2 is positive, so that works just fine. Okay, here's an ugly one. Okay, so we have a negative 2 times the logarithm, so that'll become the exponent. Okay, and then this is an understood negative 1, so it also becomes an exponent. Okay, 3 to the negative 2 is 1/9. And then subtraction can change to division. 1/4 to the negative 1 is 4. Now my ln's will cancel. Cross multiply. Add 4. 4 and 1/9 is 37 ninths. Multiply by 1/4. Check our answer. 37 over 36 minus 1 is still positive, just barely, but it is. So that answer is good. All right, and then sometimes we have exponential equations that do not require a logarithm to solve. So let's look at those. Okay, so what we want to do is compare our bases. Is it possible to rewrite 8 and 16 as a base with a power? 8 can be rewritten as 2 cubed. And 16 can be rewritten as 2 to the 4th. And once you have your bases the same, you can cancel those out. So now all we have to do is solve that. So we get 9x plus 6 equals 4. Subtract 6. And because these are not logarithms, there's no restrictions on the number here. We can actually get negative answers, and those are okay. All right. Now the next one, you're going to have your calculator because you're going to have to use logarithms to solve. So we get 10 to the negative 2x plus 2 is equal to 8. There's no way to rewrite 10 and 8 with the same base, but I can take the log of both sides. Remember, our common logarithm has a base 10, and so log base 10 and a 10 will cancel each other. And then we'll evaluate the log of 8. And I want you to go out to 4 decimal places on that. So 0.9031. All right, then you'll subtract 2. And divide by negative 2. Okay. And that's it. You can do the same thing with an e. Instead of taking the log of both sides, you'll take the ln of both sides, because ln and an e will cancel each other. So if I take the ln of one side, I have to take the ln of the other. And then ln of 5 is 1.6094. Subtract 3. And divide by negative 2. Oof. Okay. So if the base was e, we took the ln. If the base was 10, we took the logarithm. Now then there's some that's not an e or a 10. And we just get to decide which one we want to do. I personally like logarithms, so I take the log of both sides. And now then we're going to have to use our law of logarithms. So, excuse me. When we have a number multiplied times a logarithm, it becomes an exponent. We can also undo that. So if we have an exponent, we can bring it down to the front and multiply it times the logarithm. times log of 5, which is 6990. And the same thing on this one, bring the x minus 2 down, times the log of 6. Log of 6 is 0.7782. Okay, and then you distribute. Distribute on the other side. Okay, then we want to move our x's to one side. Zero 0.6198x, and then we'll add the 0.6990. And then divide. Okay, so we get x is negative 1.3833. All right, that is our logarithms and exponentials. If you have any questions, send me an email. Talk to y'all later. Bye.